Hello again, and it's time for physics, and I thought this time we'd talk about the baseball bat. And one of the reasons for that is that it's springtime and we're thinking about getting outside and playing baseball. And what I'm going to talk about even refers to golf and tennis. But let's first look at the baseball bat. Just some of the things we can measure. And just draw a bat here. Not the best rendition, but there's the bat. And we can measure the length of a bat. And so we call this the length L. And of course, it's pretty trivial, but this would be we're going to call this the linear center of the bat. But are there other centers that we can talk about? Well, we could also talk about if we take the bat and try to balance it, like that. Notice I'm just drawing my fingers together and we end up automatically at the balance point. There we are, that's the balance point. So that balance point is the, let's say it's right here. And that's the center of mass of the bat. Are there any other centers? In fact, we're looking for centers that pertain to being able to use the bat properly and perhaps hit a home run. But are there any other centers? Well, if you're a bat manufacturer, you might be interested in when you're painting the bat, when are you half done? And let's say that's right there, and we're going to call that the center of area. But that's not the center I want to talk about. I want to talk about another center. And to illustrate that center, I'm looking for a center that transfers the most possible momentum and, of course, energy to a baseball. And one way of showing this is to look at the baseball transferring energy to the bat. So I'm going to hit the bat at the bottom here with suppose that the baseball's way out here and we go like that. And it does move the bat. Or suppose we do it up here. It does move the bat. But there is a spot somewhere over here where when we hit it, oh, the bat really kicks. It's called the center of percussion. Now the center of percussion has some really interesting properties. When a ball hits the bat at the center of percussion, it doesn't transfer any vibration to the hands. In other words, it makes the bat move. It's as if it made the bat move straight that way. No wave of vibration travels up the bat. And another interesting factor is that when we get the bat swinging like this, there we go, and we make a pendulum out of the baseball. I'm going to try to make them go together. There they go. Uh-oh, the ball is getting behind. See that? This pendulum is going slower. And if we make it shorter like that, let's try it again. Oh, obviously the ball pendulum goes faster. But there is a spot somewhere around here, and let's start this again. There we go. And where the ball and the bat have the same frequency of vibration. They're getting out a little bit because I haven't got this exact. It turns out that length, let's just hold them here like this, that length right there is the center of percussion. And this length here is called the radius of gyration. I don't know if you can hear this or not, but when I hit the bat here, it makes a musical sound. If I hit it here, it makes a musical sound. In fact, I can feel a vibration there. It means that it's not really efficient. Not all of the energy is going into moving the bat. Some is going to make the bat vibrate. But if I hit it right here, you get a click, a dull click. and the bat really kicks. That's when you hit it at the center of percussion, and I feel no vibration. So if I want to hit a home run, or if I'm golfing, if I want to make the ball travel very far, if I hit it at the center of percussion, I won't lose energy through vibration, but maximum momentum will be transferred to the baseball. So have fun playing baseball, and remember, use that center of percussion.